Hi, this is Nick Bennett. In this video we're going to look at conditional statements and see simple examples of their use in NetLogo. In computer science, the term control flow, sometimes control of flow, flow of control, or flow control, refers to the order in which statements are executed and expressions evaluated. While a linear sequence of operations is sufficient for many basic calculations, more complicated computations, unpredictable inputs, or more general-purpose programs usually require a nonlinear sequence of operations. For example, it might be necessary to repeat some operations multiple times, or bypass some operations under some conditions. In this video, we'll explore one class of flow control constructs, conditional statements and expressions. Fundamentally, conditional statements are used to specify that a sequence of operations should be performed if a given logical condition is true, and skipped otherwise. Some non-programming examples of this would be, if the low fuel indicator light is on when you start the car, drive directly to the gas station and fill the tank. Or, if you hear the tornado siren, seek shelter immediately. In both cases, there are instructions to follow if some condition holds true. Also, both examples use the word if. In English, if is a conjunction that most often serves to introduce a conditional clause. It serves the same purpose in most programming languages. In programming, the generic name for a simple conditional statement is the if-then statement. Without focusing on any single programming language, the general structure of the if-then statement is shown here. Condition is a Boolean expression. In other words, one which is either true or false. In the examples just given, the conditions were the low fuel indicator light is on when you start the car, and you hear the tornado siren. Each of these is either true or false at the relevant moments in time. The statements following then are the operations to be performed if the condition is true. Note that neither example actually includes the word then, but both of them have an implicit then. In the examples, what are the operations to perform if the conditions are true? You probably had no trouble identifying drive directly to the gas station and fill the tank, and seek shelter immediately as the operations to perform conditionally in the examples. Of course, there may very well be other conditions under which we would perform those operations. For example, we might fill the gas tank before a long drive even if the fuel light isn't on immediately before we fill the tank. In programming, this would be expressed by multiple conditional statements, each with different conditions but with some operations in common. Now let's look at language-specific syntax. In NetLogo, as well as most other dialects of Logo, the if-then statement is expressed as it appears here. The required elements are the if keyword, the white space between if and the condition itself, and the square brackets. Another thing to note is that the use of the term commands inside the brackets is deliberate. In NetLogo, when we have a pair of brackets enclosing a sequence of statements, we call it a command block. The indentation in the NetLogo conditional statement is up to the programmer. So are the positions of the square brackets. Some programmers place the opening bracket on the same line as the condition. Some even put the commands in the closing bracket on that same line, especially if only a single command is to be executed conditionally. The condition can be as simple or as complicated as necessary. However, it must be a Boolean expression. In other words, it must evaluate to true or false. Let's look at an example in an actual model. I have a simple model that creates 50 turtles and then moves them around the NetLogo world in a wiggle motion. But there's a twist. In the Model Settings dialog, I've turned World Wraps Horizontally and World Wraps Vertically off. This means that the world is no longer a torus. Instead, it's a box. Notice the red lines around the small view of the NetLogo world. These indicate that the edges of the world are impassable walls. For example, turtles can no longer move off the right-hand side of the world and automatically appear on the left-hand side. What do you think happens when a turtle is at the edge of the world configured this way, and it tries to take a step that would go past the walls? When I run this model, we quickly see that turtles seem to get stuck for a time on the edges, where there are now walls. NetLogo is stopping them there, preventing them from moving through the walls. Of course, eventually they turn enough in their wiggling that they're no longer facing a direction that leads through a wall with a single step, and they can once again move forward. But I don't want them to get stuck at all. Instead, I'd like them to bounce off the walls. For now, this doesn't need to be a reflection, where the angle of reflection is equal to the angle of incidence. Instead, it's just going to be a simple 180-degree turn to reverse their direction. To do this, I'll use a conditional statement. Here in the model code, we have the wiggle procedure, which is called by the go procedure. As you can see, the maximum turn angle is only 10 degrees, so this is a pretty narrow wiggle. In the change I want to make, I still want my turtles to turn randomly, but then before they move forward, I want them to see if in fact they can't take the full step because of the walls. So I'll add the conditional just before the forward command. As it turns out, NetLogo gives us a very easy way to tell if a turtle can move a specified distance forward. The built-in reporter procedure called canMove. When a turtle invokes this procedure with a number for the distance it wants to move, the value true or false is returned. True if the turtle can take a step of the specified length in the direction it's facing, and false if taking that step would require going through a wall at the edge of the world, in which case NetLogo would stop the turtle at the wall. I want to have the turtle reverse directions in the event that canMove returns a value of false. But in the if-then statement, the commands are executed only if the condition is true. So I need to flip the value returned by canMove, making a false value true and vice versa. I do this with the logical not operator. So my conditional statement begins with if not canMove 1. 1 is the distance that the turtle will move if it can. It matches the distance specified in the forward command. Notice that the question mark is part of the name of the canMove reporter procedure, so we have to include it in our code. Inside the brackets, I need to put the command or commands to be executed if the condition is true. In this case, I want the turtle to turn 180 degrees. It doesn't matter whether it's to the left or the right. Turning 180 degrees in either direction results in the same heading for the turtle. I'll use left this time. After I close my brackets, and assuming I made the change with correct syntax, I'm ready to see the result. When I click the Setup button, and then the Go button, it's clear that the change has the desired effect. The turtles now bounce off the walls rather than being stuck. It's often the case that we want one sequence of operations to be performed under some condition, but if that condition doesn't hold, we want a different sequence of operations to be performed. In other words, instead of simply performing some sequence or not based on a condition, we want to choose between two sequences. We choose the first sequence if the condition is true, and the second if the condition is false. In programming, we call this an if-else statement, and the general form is shown here. One important point to note is that anything we can do with an if-else statement, we can also do with multiple if-then statements. The if-else simply makes it easier to express an exclusive choice between two sequences of operations. NetLogo, in fact Logo in general, has one of the more quirky syntax forms for this statement. In NetLogo, we write the if-else statement as shown here. Note that there are now two command blocks. Both sets of brackets are required. Also, if-else is written as a single word without a space, dash, or any other separator between if and else. Be careful when typing an if-else in NetLogo. One common mistake is forgetting to include the second command block. Another is forgetting to close the first set of brackets before opening the second. Let's go back to my example model and see how we might use an if-else there. Remember that when a turtle is unable to move a full step in the direction it's facing, it reverses direction before taking a step forward. There are at least two potential problems with this. For one thing, it's possible to get stuck in a corner of the NetLogo world in such a way that a turn of 180 degrees doesn't leave the turtle facing a direction where it can take a full step. So it will simply end up hitting a wall in the new direction. Another potential issue is that in the real world, turning takes time, just as moving forward or back does. The turtles in the model have already turned randomly to the right and left before checking to see if they are unable to take a full step forward. But some of them will take an additional turn of 180 degrees and then take a step forward, and it's implicitly assumed by our code that doing that takes the same amount of time as taking the step forward without first reversing direction. That might not be a reasonable assumption. I'm going to modify the movement logic in the model so that a turtle will either reverse direction or take a step forward, but not both in a single execution of the wiggle procedure. Note that this fits exactly with our understanding of the if-else statement. The turtle would choose between two different sequences of operations based on a single condition. To make the model more visual, I'm also going to use color to indicate whether a turtle is stuck against the wall, if even for a single iteration. If a turtle can't take a full step forward, I'll set its color to red. Otherwise, I'll set its color to green. First, I set the initial turtle color to green by adding set color green to the command block that follows create turtles in the setup procedure. Next, I change the if in the wiggle procedure to if else. I'll leave the condition exactly as it is, but before the left 180 in the command block, I need to add set color red to indicate visually that the turtle is at least momentarily stuck. It can't take a full step forward in the direction it's facing and must instead reverse direction. Now I add a second command block containing the commands the turtle will execute if the condition is false. That is, if the turtle actually can take a full step in the direction it's facing. The first command in this command block will be set color green to indicate that the turtle is able to move freely as desired at that moment. Next, I'll move the forward 1 that was at the bottom of the procedure into this command block, so that only a turtle that can move forward will do so. That's all I need in this second command block, so I can now close the brackets. After making the change, I need to click Setup so that all the turtles start out green. When I run the model, it looks much the same as it did after the first change, but we can occasionally see turtles at the edges of the world briefly changing color to red. In fact, there are enough turtles, and the world is small enough, that if I stop the model running at any point, there are usually a few red turtles around the edges.